So, quiz number 1, answers. Oh, let's bring our favorite student, good old Anne. She gets perfect on everything. It's great. Number 1. Number 1, although this is a written, this would be a multiple choice. This is too easy for a written. I looked at this and, they want the speed, but I see magnetic force, magnetic field. You know what? We're using the equation for the magnetic force on a moving charge. Oh, and you may have, hopefully by this time, Jake, you picked up on my notation. That's gravity. What's that one? Friction. What's that one? Electrostatic. That's the K, Q1, Q2 over R squared. What else have I? Centripetal, which could be mv squared over r, or it could be m4 pi squared r over t squared, depending on which unit, what we need. I know some textbooks use that for magnetic, but I'm so conditioned whenever I see the letter M to think mass, and I want to reinforce that that's magnetic field. By the way, B is magnetic field, not magnetic force, magnetic field in Teslas, but that's my notation. Here, Gabby, they want the speed. Okay. They gave me the force, 4.8 times 10 to the negative 14. They didn't tell me the charge. However, they told me it's a proton, so they don't need to tell me the charge. That's from my formula sheet, my data sheet. And the magnetic field, pretty big, half a Tesla. Whoop. 4.8 times 10 to negative 14 divided by bracket 1.6 times 10 to negative 19 times 0.5. Oh, holy smokes, not often something works out evenly. This is going to be 6.0 times 10 to the 1, 2, 3, 4, 5. Is that fast? Well, not for a moving charge. Actually, usually protons and electrons, we get them moving at 10 to the 6th or even 10 to the 7th. 10 to the 8th is the speed of light. The Large Hadron Collider, speed of light's 3 times 10 to the 8th. I think it gets the charges moving up to like 2.9999 times 10 to the 8th. It's like really, really close. And that's why it takes so much energy to get there. This would not be a written, this would be a good multiple choice. So the idea on your test is this force equation has 4 variables. I figure any 3 you can find the 4th. Ooh, a good written might be any 3 you can find the force, but don't give you the magnetic field, instead give you a solenoid and have you calculate the magnetic field. That I would consider a better question, maybe, because that's got some oomph to it. Number 2, wire is carrying a current as shown. Oh, it says it's experiencing a force. So we also have magnetic force on a current carrying wire. Remember, the direction of the force was determined by the direction of the current. That's why, by the way, with alternating current coming out of the plugs, that's why your wires in your house aren't jumping or moving, because it's moving back and forth. The net magnetic field force ends up being 0. So, but we still are careful not to put magnets too close to wires when possible. You'll see what happens later on when we do. What do they want us to find here, Ty? They want us to find magnetic field strength. Oh, B is going to be what? F over IL. It's going to be 1.4 times 10 to the negative 2 divided by 4 and divided by, which length? They gave me 2 in the question. Am I going to use the 8 or am I going to use the 4.2? Technically neither, because they're in centimeters. I'll convert them to meters. But which one am I going to use? The section of wire that's in the magnetic field, which is the 4.2 centimeters. I'm going to use 0.042. And I get 0.083, how about 8.33 times 10 to the negative 2? Teslas. named after a scientist whose last name was Tesla. In nerd news, by the way, they've been fundraising for 5 years. They were just able to purchase the land where Tesla's old lab is located. They eventually want to turn it into the Tesla Museum. It's in New York State. But the land itself is contaminated with all sorts of chemicals and things because it was used by industrial complexes afterwards. So they got to clean the land up first. But on my bucket list of field trips to go to someday, what would be a field trip to the Tesla Museum in New York? What's the direction of the force? Okay, so we have 3 right-hand rules. The first one simply says a single wire by itself causes or induces a magnetic field. What way? You point your thumb in the direction of the current, your fingers curl in the direction of the magnetic field. That's for a single solo wire. That's not this. The second right-hand rule was the right-hand solenoid rule. That was if you wanted to figure out in a solenoid which way, what direction the magnetic field was inside the solenoid, which way was north inside the solenoid. You held the solenoid in your hand. You curled your fingers in the direction of the current. Your thumb pointed north. The third one is called the right-hand motor rule because it also helps explain how electric motors work. This wire, you point your thumb in the direction of the current. What if it's an electron? Point your thumb in the opposite direction of an electron. Hint, hint for the test. In this case, current's going that way. Magnetic field into the page. Oh, which way is my palm pointing? Down the page. And this is why I said to you, you had to turn the page to find down the page. Right there. By the way, some teachers, some profs teach the right-hand rule that I've taught you using a pistol gun method. They go thumb in direction of current, shoot the magnetic field, and then they point their middle finger in the direction of the force. My problem is I can't bend my middle finger at a right angle. It always ends up pointing back towards me. So I use the thumb high five palm method. Whatever. You'll see there's a couple of different variations of this. I just can't do that third one. But I can cross all 4 of my fingers on both hands without having to... Okay, fine. I can do this. Anybody else? Weird birth defects, right? Yeah. Ready? Number 3. What's the magnitude of the force? Okay. Magnetic force is just QVB. Hey, this is straight plug and chug. This would be a multiple choice question probably. And even that, it's almost not too easy, but I would consider this to be close to free marks. I would say, well, I hope they would say it's an electron. 1.6 times 10 to the negative 19. Speed, 5 times 10 to the 6th. B, 0.0085 or 8.5 times 10 to the negative 3, but that was quicker to type on my calculator. Oop. Times 5, scientific notation button 6 times 0.0085. Do you get 6.8 times 10 to the negative 15? Going once, going twice. Yep. Units, Megan? Units? Megan, units? It's a force. Is that a big force? Well, on an electron, yeah. Because an electron has such a small mass. If you want to find out that acceleration, it's huge. Is that a big force on anything on the macro scale? No. But on an electron on the small quantum scale, yeah, it's huge. 3B, I like absolutely you're going to have some kind of a question where I either ask you to find the radius, although probably I'll ask you to find the radius without giving you the magnetic field. Make you calculate that. As soon as I see moving in a circle, what I'm really saying is magnetic force equals centripetal force. I'm saying QVB equals mv squared over r. Don't forget the mass. It's mass times acceleration. It's mv squared over r. Common mistake. Kids leave off the m. And conveniently, Ty, I notice, woohoo! I said, woohoo! Woohoo! There you go. Hey, Ty, what are they asking me to find?
Radius of the circle.
What variable is that?
R.
R? I went to go see a pirate movie the other day, but I couldn't get in because it was rated R. No? Okay. Yes? I've seen this before. I don't know if it's on your test, but I know I've seen it was a classic on the provincial. What is MV on top of that equation there? I've seen them often, instead of make up a charge, but instead of telling you its mass and its velocity, they would say it has a momentum of blah, 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 and a charge of 3.6 times 10 to the negative 10, and kids would freak out. They didn't tell me the mass or the velocity. Well, they told you both. They saved you time, actually. That is momentum. But here, they gave us both. It's an electron, 9.11 times 10 to the negative 31. Speed, 5 times 10 to the 6th. It's an electron. Magnetic field, 0.0085. 9.11, negative 31 times 5, 6 divided by bracket 1.6. times 10 to the negative 19 times 0.0085. Double check that. Type that right. 9.11. Good. Yep, I'm good with that. Do you get 3.35 times 10 to the negative 3? Jake, units. It's a radius. Nice. That's 3.3 millimeters, and that tells you that I made up these numbers. Really, the issue is this speed. That's slow. It really should be a 10 to the 7th, which would give you 3.35 centimeters, and that's something the human eye can spot and measure and easier to detect. But whatever. The concept is sound, Dorothy. Oh, you know what? I stuck in a tiny bit of review. Hey, what's the kinetic energy? We're towards the end of the year. Kinetic energy, that's one that hasn't changed from Physics 11. It's a half mv squared. It's 0.5. 9.11 times 10 to the negative 31, 5 times 10 to the 6th square. Do you get 1.14 times 10 to the negative 17? Joules. Why I made that 2 marks, I don't know, but apparently I was in a 2-mark binge. Number 4, find the magnetic field strength. Well, for a solenoid, magnetic field strength is equal to mu naught Ni divided by L, where mu naught, the permeability of free space, is equal to 4 pi times 10 to the negative 7. Make sure that you know how to type that into your calculator, because some of your calculators won't let you type 4 pi times 10 to the negative 7. Yep.
Yeah, I got syntax error on that.
Which tells me you didn't do it the day that I did the lesson and told everybody to make sure they tried it. So you're going to have to type, Nico, at least thanks for being honest, you have to type pi times 4 times 10 to the negative 7. You have to flip the 4 and the pi around. So you'll go pi times 4, scientific notation button, negative 7. Then it'll work. N is the number of turns of wire, 600. I is the current, 2.5 amps. Divided by L is the length, 0.04. How many Teslas will we get here? At least you found out before the test, Nico. Do you get 0.0471? Do you get 4.7 times 10 to the negative 2? Magnetic field, Teslas. Can you give yourself a score out of, I think it's out of 13, please?